Hey everybody, happy Tuesday. We're going to be doing a few examples from a couple different lessons today. I also want you guys to take a look at some of the things that I assigned on Khan Academy. That should help you with understanding a little bit more in terms of coordinate points and how to graph different equations based on the coordinates that you come up with. But today we're going to be talking about a couple different things, and the first thing is going to be how we graph horizontal versus vertical lines. I want you guys to look at just the first couple examples here. So 1, 2, and then we are going to do numbers 4 and 5 as well. But we're going to start with number 1. And you guys have a few different ways that you can now graph equations, but I think the easiest way for you guys at this point is to come up with a table that represents this equation. So on a piece of graph paper here, I'm going to come up with the table. So kind of like the tables that we were doing yesterday in class, where we have an X and a Y column, and then in between we have our equation. One other thing that we might want to notice is that 1x is the same thing as x, so I'm just going to write it as x plus 2y equals 5. So it says find at least 4 solutions to graph it. So right now, we can choose to fix either our x or our y. I'm going to fix x and pick values for y, and I'm just going to pick some really easy ones. I'm going to do 0, 1, and 2, and we should only need 3 values to really get what the graph should look like for this equation. So when y is 0, we've got 2 times 0 equals 5, and we have to add something to it. Well, we know that 2 times 0 is 0, which means that our x value has to be 5 here. So 5, 0 is going to be one of our coordinate points. If you watched the recording of or if you were at the live session that we did yesterday, you would see that we really only have to do a couple values. I know that it says do 4, so we'll do 4 for this one, but when it comes down to it, you really only need 2 or 3 values to start picking up on a pattern as long as we do have a linear relationship. So now we should see once again that we can substitute 1 in for y. So 2 times 1. And 2 times 1 is 2. So in order to get to 5, we need to add 3. That tells us that our x value is going to be 3. We'll do it with one more, and then we should start to pick up on a pattern. Really what we should see is that for every 1 we go up here, hopefully we notice that we go down 2 here, but let's test that out and see if that is going to work. If we go down 2 here, we'll have 1, and we'll have 1 plus 2 times 2, because we get the 2 from over here, equals 5. Well, yeah, 2 times 2 is 4, plus 1, that equals 5. So if we continue this pattern, what should this value here be? Now, hopefully you notice that this is always going to be going up by 1, and so this should always be going down by 2. If we subtract 2 from 1, we get to negative 1 for our solution. So the graph of this, if we're going to draw, I'm just going to draw a quick x and y axis here and plot a few of our points. We've got 5, 0, 1, 2, 3, 4, 5, and we go up 0, 3, 1, 1, 2, 3, 1, 1, 2, 1, 1, 2, and negative 1, 3, negative 1, 1, 2, 3. So we should notice that when we're looking at that graph there, it does make a straight line. We could connect the dots, but for now we're just going to leave it as points right there. Now we do have another equation that it wants us to graph as well. This time it's 1x plus 0y equals 5. Well, here's the thing. 0 times anything is 0. 1 times anything is that number itself. So we can make a really quick table of this if we're looking at exercise 2 there. And this time I'm only going to use an x and a y value, because really this equation, if we simplify it, says x equals 5. So if x equals 5, then y can be whatever we want. X is always going to have to be 5. It's not going to be increasing or decreasing. But y could be 0, it could be 1, it could be negative 1, it could be whatever value you want it to be. If you plug in any of these values, 5, 0, 5, 1, 5, negative 1, you're still going to get the solution to this equation right here. So what is this graph going to look like? Well, let's plot a few points. We've got 5, 0 once again. That line is still going to be there. Let me connect these now, just so that we can see the difference between the two. 5, 1 is here. 5, -1 is here. And we could continue that. What we should notice about this line here is that now it's a straight line going up and down. If we get an equation that is x equals something, in this case it's x equals 5, you are going to get a vertical line. So if x equals something gives us a vertical line, what do you think y equals something? Let's say y equals, see if they have that here, y equals -2. What do you think that line will look like? Y equals -2. Well, hopefully you're saying that's going to be a horizontal line. Let's take a look. If y equals -2, -2 is right there on our y-axis. Well, y is still -2 right there, and it's still -2 right there. We're going to get a horizontal line. So this is our y equals 2. This line is our x equals 5. Oh, and this should be -2, sorry. And this is our original equation. So we'll see that a linear equation typically makes a line that is diagonal. But if we can simplify down an equation that says x equals something or y equals something, we'll see more of the vertical or horizontal lines. That's actually all that I wanted to talk with you about this lesson right here for lesson 14. But if you're still having trouble understanding some of those, try some of the exercises that we have here in terms of graphing what they should look like. Now, what I also wanted to talk about is this magic term called slope. I know that you guys have heard the term slope before, but I just wanted to take a quick couple minutes to talk about slope and how we can actually find the slope without actually having to do too much math. So let's answer this first question together. Which graph is steeper? We've got graph A, graph B. If we're looking at that, we should automatically see graph B is a little bit steeper. It's going to decline or incline, depending on which way you're reading, at a faster rate than graph A is going to. How about this one here? We've got graph A and graph B. Now which one is steeper? The easiest way to think about this is which hill would you rather climb up if you're trying to exert less energy? You're going to climb up this hill, and you're going to start getting tired about halfway up. Well, this is barely a hill at all. That's not bad. When we're talking about how steep it is, the more of an incline that it has, the steeper that it is. And so when we're talking about how steep a graph is, we're talking about the slope of the graph. Now, what I wanted to talk about is how we can actually determine slope of a non-vertical line. Well, one thing that I want you to write down is when we are looking at slope, your slope is equal to how much you rise to get from one point to another over how much you run. So typically there is a number value that you can assign for a slope for a number or for a graph. If you're looking at this, we have the point 0, 0, and we have the point 1, 4. How many do we rise and how many do we run? We rise 4 and we run 1. Therefore, the slope for this graph right here would be 4 over 1. But 4 over 1 is just 4 holes. That's going to give us a slope of 4 for that graph there. Take a second to figure out what the slope of this graph is going to be here. When you think you have it, put your answer in. Hopefully you said that the slope of this line was 1, 2, 3 over 1. That means that our slope is 3. The point Q there actually isn't part of this graph. So it's there to kind of help us figure out how many we go over and how many we go up, but it's actually not important to the graph here. The line itself is what we're trying to find the slope of. So anytime that you are finding slope, you are going to find the rise over the run. Notice a difference between this graph here and the graphs that we've been looking at. Kind of like how we read from left to right, we read our slope from left to right as well. This would be a positive slope because it is increasing. It's going up as we go further to the right. This one right here is a negative slope. So if we are looking at this, and it doesn't matter which point you start at, we could either go down one and forward one, or we could go up one and backwards one. Now, if we were going to write that as a slope here, we could write that as up one and backwards one. Backwards is actually negative. Or we could write that as -1 over 1, where we're going down 1 and forward. So notice how down and backwards represent a negative slope, while up or forwards represents a positive slope. So if we're doing both of those things, it's positive. But if we're doing one and one, like up and back or down and forward, then we'll have a negative slope there. So that's pretty much all that I wanted to talk about for slope for today. Now, when we come down to it, we can show mathematically how to get the slope as well. And so that's the last thing that I'm going to talk about. And that's, I'm actually going to use this as our example here. We have multiple coordinate points that we graphed for this first table in the beginning of this. And so you can also find slope by taking two of the x and y values and subtracting to find your rise and your run. So for example, if we take 5, 0 and 3, 1, I'm going to take those 2 points. And let me actually write those where we have a little bit more space down here. So we have 5, 0 and 3, 1. Your slope can also be equal to the difference of your y's over the difference of your x's. Make sure that when you're taking the difference, you're keeping them in the same order. So difference meaning I could do 1 minus 0. This is my y value and y value. So I could have 1 minus 0 over, so that's the difference in my y's, 3 minus 5. We're going to keep it in the same order that we subtracted our y's by. So we're going to take this x first and then subtract this x over here, because we started with this y first and subtracted this y over here. So 3 minus 5, we'll have 1 minus 0 is 1. 3 minus 5 is -2. In this case, our slope is going to be -1/2. So for the original line that we wrote here, our slope is -1/2. And we can clearly see it's a negative slope. It's going down. And we rise 1 and go back 2. Rise over run, 1 over -2, or -1/2. So there's a couple different ways that we can actually show calculating slope. Make sure that you're considering these things when we start talking about slope. Once again, if you're feeling like you're having trouble with this, spend a little bit of time practicing with the problem set for lesson 15. But looking at lesson 14 and 15, that's what we should be practicing with today once we are done with this video. If you have any questions, please remember to ask me. Good luck with this stuff, guys, and we'll do another Google Meet tomorrow as a class. But if you need some time beforehand to talk about this, please make sure that you're asking me. I'm happy to set up a Google Meet so that we can discuss this together. Enjoy the rest of your day, guys, and we'll see you tomorrow.